Sound. It's literally all around us, all the time. It can be a warning, it can make us dance, it can even travel through solid steel way faster than a fighter jet. But how does this invisible force actually work? Well, in this explainer, we're going to follow a single sound from its silent birth all the way to the moment it reaches our ears.
I mean, think about it, right? What really is the difference between a gentle whisper and the roar of a passing train? One is this tiny, delicate thing, and the other can literally shake the ground beneath your feet. The difference isn't magic. It's pure science, the science of sound energy, and that is exactly what we are going to break down today.
So here's our game plan. We're going to follow the entire life of a sound. We'll start with where it comes from, then figure out what gives it a unique identity. After that, we'll see how it travels, why it's so incredibly important in our lives, and finally, a super important one, how we can protect our ability to hear it all.
All right, let's start at the very beginning, at the birth of a sound. Every single sound in the entire universe starts with one key ingredient. And that ingredient is a vibration. That's it. Every sound you've ever heard, from a pin drop to a massive explosion, starts when something moves back and forth. That little movement pushes out waves of energy, and that energy is sound. It's a simple rule: no vibration, no sound, period.
Now, these vibrations, they come from two main camps. You've got your natural sounds, think of a person talking, a bird chirping, or that deep rumble of thunder. And then you have artificial sounds, the ones made by our technology, like the hum of your fridge or the engine of a car. The source might be different, but the science behind it, it's exactly the same. It all kicks off with a vibration.
Okay, but a vibration is just movement, right? So how does that turn into something we recognize? This is where pitch and loudness come into play. They're what give a sound its unique identity.
First up, let's talk about pitch. This is all about frequency, which is just a fancy way of saying how fast something is vibrating. Think about it. A really fast vibration, a high frequency, gives you a high-pitched sound, like a whistle. And a slower vibration, a low frequency, gives you a low-pitched sound, like a big bass drum.
And what's really wild is that the world of sound is so much bigger than we can even perceive. We humans, we can only hear this tiny little slice of it, what we call the sonic range. Below what we can hear is infrasound. These are frequencies so low that whales can use them to talk to each other across entire oceans. We might feel it, but we can't hear it. And then way above our range is ultrasound. That's how a dog whistle works. Totally silent to us, but crystal clear to a dog.
So that's pitch. Now for the other half of a sound's identity, loudness. If pitch is all about the speed of the vibration, loudness is all about the force. The more energy you put into that vibration, the more intense it is, and the louder the sound gets. And we measure that intensity using something called decibels.
Let's put the decibel scale into perspective, shall we? A whisper is super quiet, around 30 decibels. You and me talking right now, that's in the nice comfortable 50 to 70 range. But this scale ramps up fast. Once you get over 90 decibels, things get annoying, distracting. And when you pass 110, that's the danger zone. We're talking sounds that are actually painful and can cause permanent hearing damage.
Okay, so our sound has been born, it has a unique identity. Now what? How does it actually get from over there to our ears over here? Let's follow it on its journey. So here's a crucial rule about sound. It can't travel in a vacuum. Like in outer space? Totally silent. That's because sound needs something to travel through, a medium. Sound waves are basically a game of dominoes, passing vibrations from one particle to the next, whether it's through the air, through water, or even through a solid wall.
And in medium it's traveling through makes a huge difference in its speed. Sound is actually pretty slow in gases like our air, because the particles are all spread out. It gets a speed boost in liquids because the particles are packed in tighter. But sound travels fastest, by far, through solids. All those tightly packed particles create a perfect superhighway for that vibrational energy, letting it zip along at incredible speeds.
So we followed this sound wave all the way to our eardrum. But why does this journey even matter? Let's take a look at the massive impact sound has on pretty much everything we do.
Just think for a second how deeply sound is woven into our lives. It is the absolute bedrock of communication. It's how we connect. It's a vital alarm system, right? A horn warns us of danger. It's the soul of our entertainment, from the music that moves us to the movies we love. Heck, it's even a powerful tool in medicine, letting a doctor listen to a heartbeat. Our world is literally built on sound.
And because sound is so important, it's absolutely crucial that we protect our ability to experience it. And that brings us to our final and maybe most practical takeaway.
Keeping your hearing sharp for your whole life really just comes down to a few simple habits. If a sound is painfully loud, that's your body's alarm system. Listen to it. Cover your ears or get away. Be really careful with headphone volume. It is so easy to cause damage over time without even knowing it. And finally, just try to be aware of your surroundings and give your ears a break from loud noise whenever you can.
So, we've gone on quite the journey, haven't we? We've followed a sound from a simple vibration, watched it get its identity, tracked it as it traveled through the world, and saw just how much it means to us. So, I'll just leave you with this one question to think about. Now that you know its incredible journey, what sound in your life truly matters the most?